Okay, so today's agenda. I hope this is visible, right? Let me maximize more. Yeah, I hope this is okay. All set? Good. Okay, fine. So today class is the continuation of our previous class. So last class we have started already the logistic regression, and this is the logistic regression part 2. So this will successfully completed the entire syllabus for the logistic regression. Okay. So as part of today's agenda, I will just go for a quick revision what we have discussed in the last class. Then we'll talk about the multi-variant logistic regression. I will try to solve one case study, that is telecom churn analysis. Then we'll see how we are taking care of the data cleanup activity, data pre-processing or preparation. Then we'll build a model. Okay. Then we'll see the feature elimination using REF. What is REF and all that I'll discuss as part of our journey. Okay. Then we will see about the confusion matrix, which I have started in the last class and giving some idea, some glance. Okay, we'll see the matrix beyond the accuracy. We'll talk about the accuracy and all, and manual feature elimination technique. We'll see. Okay, what are the different technique we are using? Okay, to eliminate the feature which is not required for us manually. Okay, then the matrix is beyond the accuracy. So not only accuracy, there are other different matrices also, that is sensitivity and specificity, that also we'll discuss. Okay. Now, once we cover, then we'll enter into a new concept altogether, that is ROC curve. We'll see what is ROC curve altogether, then what is ROC AUC score, and how does the ROC curve help us. Okay, how does ROC curve work. Then we'll talk about true positive and false positive rate. Okay, true positive rate TPR and false positive rate TPR, true positive rate, and another one is APR, false positive rate. Okay, and I'll try to formulate find out the formula of these two different terms by using false TP, AP, and all, right, by using the confusion matrix that we'll see. Then we'll see the perfect model and one random model. So these are the agenda that we are going to cover as part of today's class. Okay. So let me go quickly for the revision what we have discussed in the last class. Then once I will complete the first one, so instead of going sequentially, I will go in a different way. I will start from confusion matrix because this is the continuation process, right? I will start from number 6. Okay. Then we will complete 6, 7, 8, 9, 10, 11, 12, 13 up to 14. Then we'll take a small break. Then I will come back to point number 2, 3, 4, and 5 will complete after break. Okay. Is that fine, guys? Clear? Is that fine? So let's start then. Okay. Let's start with the first one, that is revision. Okay. Okay. As part of revision, what we have completed in the last class. So let me share my PPT so that I can discuss there itself. What we have discussed, discussed extensively the classification function. So as part of classification function, I have discussed two important classification function. One is step function, another one is called sigmoid function. Now, by taking the step function and a straight line, how I am creating the sigmoid functions that we have discussed extensively in my last class. Like I'm adding two unbounded function. One is step function, another one is called let's say straight line. As part of merging or combination, I'm creating a bounded function which is nothing but sigmoid function. Then extensively we have seen two different terminology that is called odds and log odds. And we have also completed one of the important question why we call logistic regression as a regression, not a logistic classification. Because behind the scene, we have seen there are two different concepts. One is odd and log odds. Due to this reason only, we are not calling logistic regression as classification, rather than we are calling logistic regression as a regression and all. Then we have seen binary variable distribution, okay, normal distribution curve, binary distribution curve and all. Then maximum likelihood function we have seen. Then we have understood the gradient descent and how to optimize it. Then how to minimize the loss function. So loss is basically, as we have seen in our initial class, the difference between actual value and predicted value. So for example, y actual minus y predicted. If I take the modulus value to avoid the negative component, so that is nothing but loss. So how to minimize the loss means how I can reduce the gap or difference between actual value and predicted value. Okay, that also we have seen. Then gradient descent optimization of the log loss and evaluation matrix for classification problem. So as part of evaluation matrix, I have given some introduction about the confusion matrix altogether. I have drawn the diagram. I'll show you that my whiteboard once again. That TP false positive, false negative, then true positive, true negative that I have drawn. And I have formulate. I am not formulate today class. I will formulate the formula for precision, recall, F1 score, and all. Clear, guys? Any doubt so far? Let's go back to our whiteboard. Yeah, you can see. So this is the agenda that I have said for the previous class, and we have what we have completed. Just let me go through quickly. So introduction to logistic regression, we have seen where we stands exactly as part of classification, because logistic regression is nothing but a machine learning algorithm which is used to solve a supervised machine learning algorithm, obviously, to solve a classification problem statement. Okay. Now coming to logistic regression, it is of two types. One is binary classification and multi-class classification. Binary classification means it has two different output. I mean, either 0 or 1, true or false, yes or no, pass or fail, something like that. Now coming to multi-class classification, we have more than two classes. For example, let's say I'll take animal category. So we have different animal. Whenever I will show you the picture of the animal, or I will give the animal, exactly. Then I'll tell me it belongs to which category. It belongs to elephant or camel or cow or a dog, cat, whatever it may be. Similarly, for example, I will give you the fruits item. We have different fruits. We have apple, we have orange, banana, papaya, a lot of things are there. So here I have more than two classes. As I have more than two classes, I cannot represent it by using binary classification. That's why moving to multi-class classification where more than two classes are present. Okay. Then customizable analysis, I'm giving certain introduction, that I will cover extensively. Then as part of in today's class, then as part of classification function, we have seen step function and sigmoid function. Sometimes we call sigmoid function as S curve as well, because it looks like the English S letter. So basically the step function is unbounded, but the sigmoid function is bounded. Then I have written the equation of step function. F of x is equal to 0 when x less than 0 and 1 when x greater than equal to 0. Okay. And here, three different value, either 0.5, 1 or 0. 0.5 is the threshold value here and x is equal to 0. If x less than 0, then value of y or f of x is equal to 0. If x greater than 0, then f of x value is equal to 1. Then different, between step function and sigmoid function that we have seen. and I have given one Brahmastra is nothing but how I'm creating a bounded function by taking the combination of two different unbounded things, like that is step function as well as straight line. Okay. Now I will extensively explain how by taking the help of step function or straight line I'm creating the sigmoid function altogether. Okay. Then basically mathematically how it will work, because I'm taking the probability or log odds and all, so that the range which is minus infinity plus infinity, I'm reduced down, I'm compressing in between to 0 and 1 because I'm taking the probability and all. That's why I'm making the bounded. Okay. Then we have seen the concept of odd and log odds. Okay, different formula we have derived all together. Yeah, so I have asked what is the threshold value of sigma function. It is 0.5, not 0.05, not to confuse or create any confusion, because 0.05 is the threshold value of p value, which we use in a statistical model. Okay. Yeah, then how to minimize the log loss function? As I told you, error or the loss function is nothing but error term or loss. Like, so I can write down, you may think that sir is written error, but I'm talking about loss. Same. So loss or error all are same, right? So I'm taking log loss because I'm deriving here by taking the log, right? So how to minimize that log loss function? So loss is nothing but error is nothing but difference between the actual value and the predicted value. Okay. Then I'm using through back propagation. I'm trying to adjust the value of weights and bands. You know that there is a part of the deep learning technique altogether. Okay. Now, this is the equation I have written, then evaluation of the matrix, that is confusion matrix. A 2 cross 2 matrix I have drawn, four different parameters, true positive, true negative, false positive, and false negative. Then I have just written the formula of precision, recall, score, and all. That's what we have discussed as part of last class. Okay, clear? Now, come to today's agenda. So, revision is completed, what we have discussed in the last class. So, that we have seen. So, you got some idea, kind of lots of things. Then we will continue from today's class onwards. So, after revision, as I told you, let me continue from 6th. Okay, then I'll continue. Then after break, I will complete 2, 3, and 4, 5. Then sixth one is confusion matrix and accuracy. Okay. Guys, any doubt so far? Before moving into the next concept, please let me know if you have any doubt. Let me see your chat box. Any doubt? Any doubt? Ask me here itself. Yeah. So as I have already taken the confusion matrix or evaluation matrix, let me draw the same things here today. So basically, this is a 2 by 2, or generally we call it as 2 cross 2 matrix. Means 2 cross 2, or generally people call it 2 by 2. Okay. So here in the left hand side, I'm taking the actual value, here the predicted value, and here I'm taking, let's say, yes, no, yes, and no. Whenever actual value and predicted value both are same, that is called true positive. When actual value and predicted value both are same but is no condition, this is called true negative. Because no means negative, like yes means positive. Very simple. Why true? True. Why? Because here actual value, predicted value matching. See, there are two different places where actual value, predicted value matching. One is this place, another one is this place. Because here yes, yes, here no, no. Right? But if you consider this area, this is not matching because actual value is yes, but predicted value is no. Similarly, this area, actual value is no, predicted value is yes. So that's why it is always false. Try to see the technique, how empirical. False. Why this is true? Because both are matching. Here false because both are not matching. Here no, yes, here yes, no. Fine. Now what I'll put? Positive or negative? My actual value is yes. So true positive. Here my actual value is no. False negative. So generally, typically, we call this one as type 1 error. And this one, we call it as type 2 error. There is no problem with the guys this area, this location. I can say this quadrant. Okay, no problem with this, no problem with this. Because true. The problem with this two, because that's why we call it that there is something error called type 1 error, there is something error called type 2 error. Now in some problem statement, guys, type 1 error is very important, or if false positive is very important. At that time, you have to give more priority to reduce the type 1 error than type 2 error. In some other problem statement, FN plays very important role. So you have to give first priority to FN than FP. So at that time, you have to reduce or minimize the type 2 error than type 1 error. Clear, guys? Clear? Now, as we have seen, there are three major important components we used as part of classification problem statement to find out whether that particular model is a best model, best suitable for classification problem statement or not. The first one is precision. The second one is recall. The third one is F1 score. Let me write down the formula for this quickly. So precision is nothing but TP true positive divided by TP plus FP. See here. TP true positive divided by TP plus FP false positive. Similarly, recall is nothing but TP true positive divided by TP plus FN. True positive divided by true positive plus FN. False negative. Clear? Like this area, horizontal, this line. So let me write down. So this one. For precision, it will be like this. For recall, it will be like this. Okay. Now coming to F1 score, as you know, this is the harmonic mean of precision and recall. Harmonic mean. You might have known arithmetic mean, harmonic mean in mathematics in the childhood, right? So the formula is nothing but 2 into the formula of harmonic mean is nothing but precision into recall divided by precision plus recall. See guys, generally the harmonic mean of x and y, if I tell, okay, find out the harmonic mean of x and y, then you can write down, let's say that value output is z, its output is equal nothing but 2 into x into y divided by x plus y. The same formula I am writing here. Clear? Let me put it into the box. This is nothing but my confusion matrix. Okay, confusion matrix means this matrix will call 2 cross 2 matrix is called confusion matrix. Now there is another term called accuracy. Sir, could you please tell me what is accuracy? Yes, the time has come. Now the fourth point is basically fourth important parameter is accuracy. So according to accuracy, what is telling? Guys, what do you mean by accuracy? As I told you, let's go back to our confusion matrix. As I told you, these two diagonal. Let's say I'll give the number. For example, let me give the number. It will be better. Let's say this is one. Let's say this is two. This is three, and this is four. Out of 1, 2, 3, 4, guys, there is no problem with 1 and 3. 1 and 3. Why? Because these two values are matching. Here actually yes, predicted yes. Here actual no, predicted no. Means both statements are matching. So there is no issue with that. But the problem is only these two diagonal. So when I'm telling accuracy means accurate. Now tell me in which two quadrant value are accurate? 1 and 3, because here only the values or the statement are matching. So if I have to find out the formula for accuracy, then it will be true positive. Let me use the red color. True positive plus true negative. These two, because I told you there is no problem with that. True positive, true negative, right? Divided by total sum. What is the total sum? True positive plus false negative plus true negative plus false positive. See, all the four quadrant value. True positive plus false negative plus true negative plus false positive. Okay, this is nothing but my accuracy formula. So this is my accuracy. If I find out accuracy, then it will be like this, like this. TP plus TN divided by all the four. TP plus TN plus FN plus FP. Okay. Clear, guys? Any doubt so far? Let me go back to your chart and see. Let me draw a small diagram here. Okay. Generally, where I can I draw here so that you can compare? Okay. Let me draw here. Okay. Oh, let me use the black color. Okay. Here you have taken actual, right? Let me take it predicted. And here I will take actual. Okay. So this will be no doubt yes, no. This will be yes, this will be no. Okay. This is both are matching, so true positive. Here no matching, so false negative. Sorry, true negative. This is true positive, this is true negative. Now as I have taken here, let me here I am giving more focus on actual value. Listen to my point. Four different cases you can generate, but don't confuse, all are same. That's why I'm what I have written, stick with that, or you have to stick with any of the things, otherwise you will be confused in the exam. Okay, listen. Here I have taken actual, right? But here I am taking actual here. Here I have taken predicted, here I have taken predicted. My first priority actual. Based upon the actual value, I am deciding whether positive or negative. Think about that. Now, see, here yes, here no. Not matching, so obviously it will be false. Here no, here yes, so it will be obviously false. Now, as I am giving more priority to actual, wherever actual, I told yes means what? Positive. Think about this. Say true or true. Yes means positive, no means negative. Means because it will match. No, A no. Start with N, so it will match N. So yes means positive, no means negative. This is a trick. You have to think back of your mind. Now tell me. Here I am giving first priority to actual. So as actual value is yes, so it will be false positive. Here, if any of, because both are not matching, false. And here I am giving more focus first priority to actual. So actual is no. So false negative. Now see, I have taken false positive here, false negative here, but it's a reversal now. Now it's a false positive, false negative. Now one more thing. Here I am giving more priority to actual. Let's say in this case, you are giving more priority to predicted. As predicted, let me draw one more time. Okay. So four different cases you can generate. Hold on. Now it will be clear 100%. That's what I'm telling you. Observe what I'm telling, my wording and what I'm writing. So here, let's say, just a mirror image of this one. Okay, again I'm taking same actual, actual here, here predicted, okay, and here yes, here no, here yes, here no. Okay, I told the clue is yes means positive, no means negative, yes means positive, no means negative. Fine. Now tell me, yes, yes matching. So this is true, positive, no doubt you are true. Yes means what? Positive. True. Why true? Because both are matching. Here no. So both are matching means first true will come, obviously. Then n means negative, true, negative. No problem with that. Because this diagonal is always fixed. You take any of the condition, either this case true positive, true negative, true positive. That's what I there is no problem with this diagonal. This diagonal. Okay. Now tell me. I hope you are observing, right? Yeah. Now tell me here. Guys, here both are not matching. Yes, no. So it will be false, no doubt. Let me write on F. Here also both are not matching. No and yes, so false. Now tell me in this case, for example, I will give more priority to predicted. As predicted is no, I mean no means n, so I will put n here. False negative, because I'm giving more prior to predicted value, not actual value. Here, my predicted value is yes. Yes means positive. I will give positive here. Now see, try to compare this picture with the above one. This is same, right? I have taken actual here, predicted here, actual here, predicted here, predicted here. But if you see, sir, in the previous diagram, hold on, let me complete, hold on, let me complete. Here you can see my false negative here, my false positive here. But here, I'm taking false positive here and false negative here. So whatever you are telling this condition. Sir, you have taken wrongly. Why? Because I have taken false positive here and false negative here. But you are expecting sir should write like this. When I should write like this, whenever I'm giving predicted as my high priority than actual value. But here I'm giving high priority to my actual value. Based upon my actual value, I'm writing positive or negative. You getting me point? And for this also same similar thing, I can draw one more diagram. Let me complete, then I'll come back to your question. Okay. Here, what I've taken, it will also reverse now. Here I've taken predicted actual. Let me take predicted actual. Predicted actual, and this is yes, no, yes, no. Fine. Now it will be true positive, obviously. This will be true negative. Now, in this case, what happens, guys? I'm giving more priority to predicted, as I told you, right? Predicted, right? Predicted or actual value? 1 minute. Here I'm giving actual value. Okay. So here I'm giving more fast priority to actual. Let me put this symbol so that you can understand. Actual. Here in two different below two cases, I'm giving more value priority to predicted. Now tell me. So yes, no, not matching. So it will be false, obviously. No, yes, not matching. It will be false. Now tell me whether it will be yes or no, because I'm giving more priority to predicted value. As predicted yes, yes means positive, it will be positive. As I'm giving more prior to predicted, here predicted no, no means negative. Now you compare this one. Let me give the picture number 1. This is my picture number 2. This is my picture number 3 and picture number 4. Now you compare picture number 2 and 4. 2 and 4. Here is 2 and below is 4. See, here I am taken predicted here, actual here also same. Predicted actual. But see, this diagonal, as I told you, it is the same for all the 4. No problem with this. It will be always constant. See, this will be same. You take any diagram, it will be true negative, sorry, true positive and true negative. Places are same. It won't change. Clear? Now tell me here, my false positive present. But here in the below, it will be false negative. But above, here false negative present. But here, false positive present. Do we think that this is wrong or this is wrong or this is wrong or this is wrong? No. All 4 are correct. Only thing is that what are the assumptions they have taken. In some books you will find picture like this. Some books you will find picture like this. Some books you have to find picture like this, and in some other maybe books or maybe YouTube or maybe website you will find like this. But by seeing this, you cannot say, oh, this is wrong, that is wrong. No, there is some assumption written in the below. Try to read those notes or assumption what they have taken. Then you will get to know nothing is wrong. All four are correct. Guys, we have done a lot of arrange on this. Okay, that's it. And I fix with only one because if I show you all the four, you will be confused. And if you want to draw the diagram in the exam, it will be getting a lot of confusion. That's what I try to fix. There is no problem with that whether you are taking actual here or actual here. No problem. You take actual here or actual here, predicted here or predicted here. Fine. You take predicted value as a high priority or actual value as a high priority. No problem with that. Try to understand the concept. If you are giving more priority to actual, then based on the actual value, you have to decide whether positive or negative. Then automatically that will be come whether it will come in this quadrant or in this quadrant. But anyhow, true positive and true negative, there is no change in the quadrant because that is fixed irrespective of any other assumption. Here see, this will be in the right set, right diagonal, right? No changes in the true positive, true negative. Only these two will be changed. That's what I'm telling. Don't see what I'm drawing. The assumption I'm also taking, try to go through that. Clear hearts, now tell me what is your doubt. So we have completed accuracy, right? So what is next? Yeah. Now another two different term that is called, how come it come in the below, manual elimination, feature elimination. Okay, I'll cover after this. Okay, yeah, come to here. I mean after that. Matrix given accuracy and accuracy, that sensitivity and specificity. Okay. So till now, point number 8. Sensitivity and specificity. Okay. So till now we have seen four different important parameter, that is precision, recall, F1 score, and accuracy. Right? These four. Obviously, these four are playing very important role in the classification problem statement to decide whether that particular problem statement is a working fine or is a good fit model for a particular problem statement or not. But that is not sufficient again altogether. In addition to these two, these four, another two major important parameter also there that we are going to discuss here. One is called sensitivity. Let me write down. This is 50 important one. Sensitivity. The sixth one is specificity. Okay. Then what is the formula of sensitivity? Sensitivity is nothing but telling true positive divided by true positive plus false negative. I'm always, whatever formula I'm writing, I'm sticking with only one. That is the first one. Whatever I've written. Okay, the major one. Okay, don't confuse the other three because that I've explained as horse not the doubt. Because whatever the formula I'm deriving on the standpoint of the picture number one. This one only, major one. Okay, so don't confuse like if you recall. Okay, true positive and true positive plus false negative. Then you will think that okay, true positive. I mean, I know the formula is same, but you will get confused. So stick with any one of the diagram. Okay, that is the main thing. You go to formula, stick with this diagram, means stick with this diagram and create all your formula based upon this diagram. Okay. Don't think like for precision I'll use this one, for recall I'll use this one, for F1 score I'll use this one. It will create confusion actually in your mind. Okay, nothing else. Sensitivity is equal to true positive divided by true positive plus false negative. Okay, and the specificity is equal to, that is false negative. Okay, let me write down the formula first. Okay, just 1 minute. Let me write down the formula, then I explain. the formula. Yeah, 2 negative divided by Tn. 2 negative divided by 2 negative plus false positive. 2 negative plus false positive. Okay. Now, guys, let's talk about the specificity. It's written 2 negative divided by 2 negative plus false positive. What is 2 negative? 2 negative here. 2 negative divided by 2 negative plus false positive. False positive means this one. This part. This part. Fine. Now, let me put into the box. Now, the fifth one is sensitivity. It is telling true positive divided by true positive plus false negative. Now, let's see. What is true positive? True positive divided by true positive plus false negative. Yeah, so already I have marked with a blue color. That means this formula we have derived before. Where we have derived, could you please check? True positive divided by true positive plus false negative. Wow, this one. True positive divided by true positive plus false negative. That means, guys, you know what does it mean? It means the other name of the recall is sensitivity. Sensitivity. Clear, guys? Because both the formulas same. You see the formula number 2. True positive divided by true positive plus false negative is same as the formula number 5th. That is true positive divided by true positive plus false negative. That means recall or sensitivity both are the same. Just the synonyms kind of things. Clear, guys? Any doubts so far? Any doubts so far? If no, then let's move to the next one. Okay, it's very important things. What is ROC core? Point number 9. What is ROC core? Guys, any doubt so far? Okay. Now, before get into what is ROC core, try to understand what is the full form of ROC. Let me write down first. ROC nothing but receiver, RECIVR, receiver, operating, OPERAD, operating characteristics, CHARA characteristics, CHARCT characteristics. Okay, receiver operating characteristics. Let me draw the diagram first. Okay, then I'll explain. Guys, if you want to draw a 2D axis, I mean 2D plane, x axis and y axis, let's say this is my x axis and this is my y axis. And in x axis, generally I'm taking one important parameter called false positive rate. There is nothing but FPR. Similarly, here in the y-axis, in here this is my x-axis and this is my y-axis. In y-axis, I'll take true positive rate. And if I will draw a diagram between the false positive rate and true positive rate, then a diagram will draw looks like this. And if I draw just a perpendicular line where it touches the x and y axis, I mean generally it exponentially increase and after certain time it will be stagnant. Okay, so let's think about it touches the y axis here. and x-axis here. So let me write down this is FPR, false positive rate, and this is my TPR, true positive rate. Then this red color curve, this red color curve is called ROC curve. Why you use this curve? In what sense it help us? That we'll see one by one. Nothing to be worried. Just try to understand what is ROC curve. Basically, ROC curve is nothing but a kind of curve. Obviously, the full form of ROC is receiver operating characteristics. If I will draw the diagram in the 2D axis in between the false positive rate and true positive rate. Anyhow, the false positive rate I have to take in the x-axis and true positive rate I have to take in the y-axis. If you take a reverse, like true positive rate in the x-axis and false positive rate in the y-axis, then it will be different curve, kind of like this. Okay, so you have to take that assumption. Okay, then a curve looks like this red color map, red color curve. This is called ROC curve. Okay, receiver operating characteristics. Any doubts so far? Any doubts so far, guys? Please let me know any doubts so far. Okay, so ROC curve is completed. What is ROC curve? ROC curve this is completed. Now we'll see what is a ROC AUC score. That is very important. Okay, what is a ROC AUC score? This is 9 and 10 we have completed, right? What is ROC score? Guys, ROC I have written the full form of ROC is nothing but receiver operating characteristics. Similarly, what is the full form of AUC? The full form of AUC is nothing but area under core. Guys, very important. Try to understand. Definitely get the question or the by the question or the interview question maybe in the semester exam. Okay, we'll get this. Okay. What is AUC, area under curve? Then how this AUC score? What is the score? Obviously, it will be something, some numerical value that we will see. Based upon that AUC score, how to decide? Okay, whether it is a perfect model, good fit model, or it's a kind of random model. It's not a good fit model or not. Okay, try to see. Now, let me draw the same diagram once again to explain you what is AUC score and all. Okay. So again, I'm taking the x-axis, y-axis, and x-axis. And in x-axis, obviously, I'll take. Let me draw it. This is my y-axis. And here, if I draw a diagram, it will looks like this. Obviously, it will look like this. It will go like this. Okay. Then this is nothing but my false positive rate. Okay. And I'm not writing the full form because I've written here. Okay. True positive rate. True positive rate. Okay. What happens? Something got disconnected. Yeah. So if I draw the diagram between APR and a TPR, false positive rate and true positive rate, and obviously if I draw the dotted line, it will touch us somewhere in the y-axis and x-axis. That is none of my business. So basically, the area under the curve. I mean, this is the curve, right? This is ROC curve, ROC curve, CURV. Okay, ROC curve. Now the area under the curve means this part is called ROC AUC, area under curve. ROC AUC. Okay, let me use the highlighter so that I can draw it quickly, you will get a clarity, 100% clarity how it looks like. So let me just mark it. So I have to go with this. Okay. So the area under this. Try to cover. Getting my point, guys? This core. Under the ROC core, what are the area it capture, that is called ROC AUC. Then it has certain value, guys. Can I try to understand? All of you, sorry. All of you clear? Now, based upon this ROC AUC, there is certain value. I'll decide whether that particular value, based upon that value, it is a perfect model or random model. I'll explain this. Based upon, sorry, let me change the color. Yeah. Based upon this perfect ROC AUC value score, which is nothing but score, I'll decide whether it's a perfect model or random model. Guys, before getting to that, let's try to see the what are the two different terminology I have introduced today. That is true positive rate and false positive rate. What is the formula of this? I want to represent in terms of TP, TN and all, like confusion matrix, true positive, false positive and all. Okay, so this is nothing but let me write down my true positive rate, and this is my false positive rate. Clear, guys? Any doubt so far? Any doubt so far? And we'll explain how to do it. Obviously, after that, but let me represent first. Okay, how I can represent the TPR and APR, true positive rate and false positive rate, in terms of confusion matrix. Okay, now, clear, guys? No doubt so far? Now, point number 30. In short, I'm writing TPR and APR formulas. Fine. Now coming to TPR, let me write down first TPR. TPR. Another one is called APR. Okay, this is also kind of different evaluation matrix. So 6, right? So this is 7. Let me write down this is 7. This is 8. Okay, this is 7 and this is 8. Fine. Now coming to TPR. The formula of TPR is true positive divided by true positive plus not visible. Whiteboard is not visible. Okay. Somebody was telling, sir, diagram. I think your plot was not displayed. So you can see, I'm talking about the ROC core. If I draw the diagram in between APR, false positive rate and true positive rate, then the area under that ROC core is nothing but ROC core. Basically, the area under core. Okay. So based upon that value, I'll decide whether my model is a perfect model or random model. That I will come. Okay, I'll decide in the last point based upon that value. Value means score, AUC score, right? Because the 11 point I've written what is AUC-ROC score. Okay, I just show you where my AUC-ROC present, area under curve present. Now, based upon that value, it is some certain value, right? Numerical value. Like how we have predicted the threshold value for sigma function, that is 0.05, sorry, 0.5. P value, threshold value 0.05. Similarly, ROC AUC score has certain value. Based upon that value, that range, I'll decide whether it belongs to perfect model or random model. That we'll see. Okay, don't worry. So before that, what I'm explaining, I introduced two different, terminology. That is true positive rate and false positive rate. I'm trying to formulate for those two different important parameters. Who has asked me is unable to see, right? Fine. Is it horse or is it Dhanush? I don't know. Fine. The true positive rate formula is Tp divided by Tp plus Fn, means true positive divided by true positive plus Fn. Clear? Now similarly, the false positive rate formula is Fp. Let me write down Fp divided by false positive divided by false positive divided by false positive plus true negative. False positive plus true negative. Okay. Let's try to see. First, let's try to see the APR. False positive divided by false positive plus true negative. Let me go back. So false positive divided by false positive plus TA, true negative, true negative, true negative. Means this one. False positive divided by false positive plus TA, true negative. Fine. Now, what's about TPR? What's about TPR? TPR is nothing but TP, true positive rate, true positive divided by true positive plus false negative, true positive divided by true positive plus false negative. Oh, already I have given the blue mark. Like that means I have drawn the formula. Where is the formula? True positive divided by true positive plus false negative. Oh, it's matching with the recall only or sensitivity. Now can I tell the other name of recall or sensitivity is equal to TPR? I'm deriving the formula. That's why by knowingly I am doing all this hangama. See, that means the formula for recall, sensitivity, and TPR, true positive rate, both are same. These are the synonym. If somebody will ask, instead of asking what is recall, they maybe ask what is sensitivity. You may be flat. Sensitivity? I don't have any Sensodyne, no problem. Let me consult with a dentist or doctor. Said like Sensodyne, you will think the Sensodyne Colgate, toothpaste and all. Right? This is not Sensodyne. This is sensitivity. So recall or sensitivity or true positive rate, both are same. Okay, just synonym. Okay. Similarly, guys, let's try to see. I have drawn one more formula, that is false positive rate is FP divided by FP plus TN. So FP divided by FP plus TN. I am marked the blue mark. That means somewhere I have drawn the formula before. Let me see where FP. Where is FP present? FP. Where is present FP? Or by mistake I have drawn. I don't know. FP divided by. How come I have drawn this one? FP divided by. This is TP divided TP plus AP, okay. This is fine. Now sensitivity TP divided by TP plus FN. TP divided by TP plus FN. TP divided, okay. That's it for TN divided by TP plus AP. TN divided by, okay. This is TN divided by TN plus AP, okay. That's why I make it. But it's not the same formula like this one. APR. Okay, so this is the different formula. Let me put in box. So what are the different formula I'm deriving? That I'm putting in the box. What is similar that I'm not putting in the box? Otherwise, you'll feel that we have 8 different formula, but we don't have 8 of different formula. Even though I make it 8 different parameter, TPR, sensitivity, and recall all are the same. Now let me just go for a revision. Yeah, I'm starting from here. So precision having unique formula, recall having unique formula, which is matching with sensitivity and TPR. That's why I make it a box. Now different different formula. That's why I make it a box. Now accuracy different formula. I make it a box. So four different formula. Sensitivity same as recall. As I make putting into box. That's why I'm not putting into box here. Now specificity having different formula. So you can consider here one, two, three, four. Then a five different formula. Then again TPR six different formula. So I'm not putting TPR into box. Why? Because TPR is the same as the recall and all. Okay. So we have six different formula that we have derived from confusion matrix or from by taking the help of true positive, false positive, true negative, and false negative. Getting my point, guys? Clear? All of you clear? Okay. So 13 number point has been completed successfully. Successfully. Now 12. Sorry. Let me change the color. Now 12. How does ROC curve work? Okay. How does ROC curve work? Fine. Guys, clear? Any doubts so far? Any doubts so far? Let me see your chat box. Yeah. So how does ROC curve work? ROC use curve work. Okay. Sometimes before I told you, guys, there is certain called score. ROC use score. What is the score all about? Let me write down fast. Okay. So coming to the score, guys, there are basically two different. Let me write down AUC, ROC, AUC score. Okay. There are majorly two different value altogether. Okay. If ROC AUC score is 0.5, 0.5 is kind of 50%, then that model is called random model. And if it is 1 is 100%, okay, 100%, then this is called perfect model. So let me use a different color. So 1 means basically I can say 100% coverage. 0.5 means 50% area, 50% of area. This is 100% of area. Clear? Now, based upon this value, I will decide whether it is a perfect model or a random model. Now, the time has come to see how does a perfect model looks like, how does a random model looks like. Okay. Now that we'll discuss the 14th number point. That is perfect model and random. Okay, perfect model and random model. Okay. Let me draw the diagram. X-axis, Y-axis, false positive rate, true positive rate. Okay. If I draw a curve, okay, think about that. Let's say, for example, I'll draw a dotted line. This is very, very interesting. Okay, can I? Okay, let me. Sorry, let me make it bigger. So let me erase it. Let me draw it a little bit. Yeah. Think about this. Okay. Now let me draw. Now guys, tell me if I will take. Okay, let me think this way also. I'm able to see the total rectangle. It's kind of rectangular square kind of things, right? If I take, then this will be 100% correct. If I take any half, maybe this one, this green color mark with the below this one, then I can say, can I say this is 50% of area? Then above 50%, are you getting my point or not? So here, below this area, this area, this area, all 50% above this area, all this area. This is 50% or not? 50% or not? Now, whenever I'm telling 50%, that means it's telling any part. Let's say this part only. This part only. Let me draw the proper way. Not the above part. Okay. Below this green color line. Okay. This is called 50%. If the area under the curve, anyhow, this red color mark, if I extend it, this is nothing but ROC curve, you know, right? If I extend it, this is nothing but my ROC curve. The area under ROC curve, just cover with 50%. Then this model, if this model is called a random model. If it is 100%, cover the above 50% also. So I don't want to make it complex. Think about that, the above also. So can I change the color? Is it possible to change the color? Yeah. Let me change it if possible. Which color I'll choose? Let me change this color. Okay. So let me try to do. Yeah. In a different color I have put before. That is fine. Think about this part. So if I will assume only half, either the below orange color or the above blue color, that is 50%, that is called random model. If I will take the combination of both, the above 50% and the below 50%, then it will be 50 plus 50 is 100%. That is called perfect model altogether. Clear, guys? Any doubt so far? Any doubt so far? Yeah. Clear. Now, the entire thing, blue plus this orange, this is called 100%, which is the example of, what to write? Yeah. Example of both. Combination of blue area covered by blue color plus orange color. Okay. This is the example of perfect model. I'll share my PPT with you, and I'll show you some beautiful diagram. Nothing to be worried. Guys, clear? Concept wise clear. Any doubts so far? Any doubts so far? So when I'm telling random wallet, don't think that only below is the random wallet. Either this one or this part. Only this part also called here random model, right? Just 50% random model. But if I take the combination of both, 50 plus 50, it will be 100%, which is nothing but my perfect model. Clear, guys? Any doubts so far? Any doubts so far? So let me go through my PPT quickly. So what are things we have explained or covered in the whiteboard? Same things is written in my PPT or anything else or anything we left that also we can see. Okay. So let me quickly share my screen. See, the ROC we have started. That is receiver. The full form of ROC is receiver operating characteristics. We're trying to draw the diagram between false positive rate and true positive rate, TPR and APR. Okay. So how a curve looks like this? A typical curve looks like this. In the x-axis, I'm taking false positive rate. In the y-axis, I'm taking true positive rate. Don't take it in the reverse. Otherwise, the curve looks like this, upward, something else, not like this. If I draw, I mean, this red color plot, I can say curve is nothing but ROC curve, receiver operating characteristics. Okay, fine. Now, what is the ROC AUC is the receiver operating characteristics, and AUC stand for area under the curve. How it looks like this? Yeah, this one, this part. You can draw the diagram, false positive rate and true positive rate. You can see the area below that curve, ROC curve is called AUC-ROC, area under the curve. Okay, it has two different typical value. Okay, one is 1, another one is for 0.5. Generally, a typical, a higher ROC AUC indicates better performance because I just told you, so AUC or ROC AUC value 1 is a good value. That's why we call it a perfect model. So higher the value, to be best. If lower, like 0.4, 0.3, 0.5 and all, that is called random model and all. Okay. Now you see, how does it work? Okay. So I want to represent here by taking the help of true positive and false positive. Here you get to the formula I have already written, right? TPR and APR. Okay. No need to spend much time, which is the same as the recall value and all. TPR value. Okay. Now, false positive rate, generally we call it as a kind of false alarm rate and all. Okay. Now, yeah, so one point. Classification threshold. Generally, you can see if it is 50-50 percentage. Why it is not good? As I told you, random model. In case of C, other and target value, if probability is greater than 0.5, you can see that the line, red color line is present in the middle only. But if the probability is higher than 80 percentage, means towards 1, then you can see your red color mark is going just beyond the half position. Okay, that is the classification threshold and all. Okay. Now you can see it's a good representation. I have taken false positive rate, true positive rate. I have got this blue color mark is nothing but my ROC curve, right? I have just divided it into 50-50 by taking the help of red color mark. Okay, whether you take the above one or below one, that is called random model. Perfect. Now, if I take this green color area, this total rectangular, or you can say square, this one, this part, this part, this part, and this part, this is called perfect model. Why? Because I'm adding below 50% and above 50% of the red color mark. That is called perfect model. Now, two model I am representing in the same diagram. Random model, perfect model. So it may clear confusion. That's why for simplicity, in the next diagram, I have separated two diagrams. Okay, two models. Then you can visualize in a better way. See, same things whatever I have drawn in the same diagram. Maybe you are getting confused. That's why I draw two different diagrams. If it is below this red color mark, which is AUC value is 0.5 means 50% area, that is called random model. Random model is written, right? Random model. If it is entire value, which is equal to 1 means 50% plus 50 or 0.5 plus 0.5 is nothing but 1. That is called perfect model. Written, right? Perfect model. Perfect model. Clear, guys? AUC value is equal to 1. Same. False true positive rate and false positive rate. Okay. So this is the entire area, that is AUC is equal to 1. This is half of the area, that is AUC is equal to 0.5 is nothing but random one. Clear, guys? Any doubt so far? Any doubts? So this is what we explain as part of our whiteboard also. Okay. So we have covered all the things. Now we'll start from the point number two. I'll try to solve a business problem statement. How we are? What is the approach to solve the problem statement? Okay, that we'll see. Fine. So telecom churn analysis. Telecom. Yes, you are in churn analysis. Guys, could you tell me what do you mean by churn? What do you mean by churn? Okay. To make it simple, let me give you an example. Through example, I will explain. Okay. Think about in the market, there are a lot of, in telecom sector, there are a lot of operators, okay, vendors that are present. Let's say I can say the number one operator competitor is, let's say, Geo. Then we have something called Airtel. Then we have something called, let's say, BSNL. And we have other things also. I am not writing all, let's say, Vodafone, Idea, whatever, others. I am writing others. Yeah. So we have something called Airtel. Okay, it's disconnect. Then BSNL. Then we have something called Vodafone and others. I'm writing others. Others means including Vodafone, Idea, whatever. Okay. Now guys, tell me one thing like what do you mean by churn? You might have seen generally whenever a people who are, let's say one existing customer or if people are using Geo, okay, let's say you are using all of you using Geo. Few months before you might have seen there is a hangama was going on in the market. आज our mota bhai, okay, you are celebrating his son's birth, marriage ceremony. He all of a sudden increases the price of recharge, right? All maybe 1 month, 3 month, whatever may be. Okay, he increases. Lot of customer get frustrated at that time. I have seen also lot of people start switching from Geo to, let's say for example they are switching to Airtel. They are switching to Airtel. Few people also they are trying to switch to BSNL or not. All. Now, guys, whenever a customer, existing customer, want to exit from the existing operator and try to get into another operator, anything else, maybe BSNL or Airtel, it's not like that always, cost is the reason that high cost. It may be a different reason, maybe network. Wherever you are staying, maybe there, Geo network is not coming absolutely fine. Maybe there Airtel and BSNL are working fine. But while talking, most of the time call is getting disconnected due to poor network. But at the same time, let's say your friend is using Airtel and BSNL, they are enjoying. I mean, there is no call disconnected. Bandwidth is good. Data. I can say speed is absolutely great and all. So these are the different reason why a person or the customer want to switch from the existing telecom network to the other competitor network. That process is called churn. Churn means the process of switching from the existing network to other network, that is called churn. Now we are here to do the analysis. Why? Why a customer want to switch from existing network to another network? For example, after completion of your BTech, you got a job in Geo. Okay, let's say you join as a data analyst or data scientist, something like that. So they give this problem statement. So you have to work on telecom churn analysis. Why most of the, let's say they observed in 2024 or maybe 2025 in January, February month, we have seen almost, let's say, 2 crores customer they switch from Geo to some other network. Why? What is the reason? Then you figure it out. Okay, as they have increased the recharge price, that's why a lot of people they switch. Some other region maybe in the hill station and all, maybe let's say it may be Himachal Pradesh, SP and all some other things. So there maybe Geo network is not good because they are not providing the Geo tower and all. But Airtel and BSNL they have the proper network. That's why people are trying to switch. Who belongs to that area, not hill station area and all. Fine. So these are different typical reason you figure it out. Then for that, what happens generally? As part of our discussion, generally we are taking three different data sets. One is customer data set, customer data. Another one is called, let's say, internet data. Third one is called, let's say, churn data. So data set in the sense, think about this kind of table, it contains certain columns and all. Okay. Certain columns and certain value also, right? That I'll show you when I will share my PPT. Okay. It has certain column also. Fine. Clear. Now what will happen, guys? As this is three different data set or data frame or table, whatever you call. If I want to merge all together, I will combine together, then obviously I have to apply the join concept by maybe by taking the help of SQL or maybe pandas data frame or PySpark data frame or whatever it may be. To combine different tables or data frame, there is a thumb rule. At least one column should be common. So that one column I figure it out, there is a common column among all these three different data sets that is called customer ID. customer customer ID. Okay, this column present in this data set, in this data set, in this data set. So based upon this common column only, I will able to join all these three different table or data set all together. Then finally, I will get a data set which is huge because I'm trying to combine all these three, right? For example, here 9 columns are there, 5 columns are there, here 9 columns are there. So altogether 9 plus 9, 18 plus 5, maybe 23, 24 columns will come here. 23 to 24 columns will come here. Okay, that will see. And obviously data will be present. Clear guys? Any doubt so far till this point? I hope no doubt. Fine. Then what happens? As I told in the last class, whenever we are extracting the data from a source system, it's not like that. For example, in the source system, I have 40 columns are there. 40 columns are there. Do you think that all the 40 column related data are required for my further analysis? No, it's not required. Maybe out of 40, I need 16 to 20 columns. Then how to figure it out? Why these 16 to 20 columns are important for my further analysis? For that, I have to implement different methodology or techniques. One of the methodology that we are discussing as part of our previous classes that is called p-value. Based upon the p-value, have you remember or forget? So in the statistical modeling, we have learned statistical modeling. There are two different p-value. Even in the previous class also I have explained, right? So why I'm taking modulus? Because it won't be negative value and all. Okay. So if my p-value, let's say it has two different value, as you know, okay. So if it is less than equal to 0.05, okay, then I can say accept null hypothesis. Hypothesis means that column is important. Column is important. If it is greater than 0.05, then reject null hypothesis and that column is not important. Clear, guys? Any doubts so far? The column is not important. Then similarly, p-value, there is another methodology also there by using which we can figure it out whether we need to consider that column or we need to drop that column for further analysis and all. That we'll discuss one by one. This point is clear. Any doubts so far? Any doubts so far? I'll show you this one as part of my activity. I'm building fast model and feature elimination using REF. What is REF and all that I'm going to discuss. Okay. Feature elimination using REF. Okay, so before getting to that, getting to this, let's try to share my PPT and I'll show you what are things we have discussed and some other a diagram and my three different data set as I told you, right? These three different data set. Okay, these three data set and how the merging going on, data pre-processing activities also going on. Okay, so let me quickly share my PPT. See, the problem statement we are going to see the telecom churn analysis. Fine. So as I told you, three different data set. One is called churn data, another is called customer data, third one is called internet data. You might have seen, there is a common column between all the three. Sorry, guys. Okay, there is a customer ID column present here. There is a customer ID column present here. There is a customer ID column present here. So in all these three different data sets, there is a common column between all these three different data sets that is called customer ID. Okay, that is what is written here also. You can see. I'm not spending time to read all this text, right? Whatever I explain, same things written here. Now, what I'll do, based upon this customer ID, I will try to merge it, right? I can merge, you can see. In order to build the model, it's important to first clean and prepare the data. This involves merging the three different data frame or data set or table, whatever you told, right? So these three different, like churn underscore data, customer underscore data, and intern underscore data, based upon the customer ID. Now, once I will add it, guys, so it will create a huge big data frame altogether. You can see. I'm showing here. You can see it contains lot of columns because it will combine all. Let's say here, see, very simple. Here, let's say I don't know. I have not counted. See, let's say here, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 columns are there. Here, 1, 2, 3, 4, 5. Right, 5. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 plus 9, 18. 18 plus 5, how much? 23. Three columns are common, so leave another two, leave it. So 21 columns around. So all the 20 columns are required, not required. All the 20 columns may not require for my further analysis. So how to drop that? Because to drop that, generally, guys, one more technique also I've taken here. Let me show you which columns are important. Yeah, that's a heap map. That's called heap map. By taking the help of matplotlib and cbon, which is the visualization library given by the Python, I can draw a diagram, a plot like this heat map. Then it will tell me all this black color area. You can see the columns are strongly attached. If strongly attached, like multi-collinearity is there, then you have to drop only one column. You can consider another column for the further analysis. That is the one thing. Second one is p-value. As I told you, you have to find the p-value, probability value. If the value of the column p-value is less than 0.05, then you have to consider. If it's greater than 0.05, then you have to ignore it. Clear, guys? Now, once you do, then the REF is nothing but feature elimination. Okay, feature elimination using REF. Let me come back to here. The full form of REF is recursive feature elimination. Okay, recursive feature elimination. As part of this technique, guys, there are two different things. One is p-value, another one is called VIF, variance inflection factor. Here you can see. By observing p-value and VIF, variance inflection factor, which comes under REF, you can decide which column you need to consider and which column you need to drop. Okay, so I have already explained the p value. Let's try to explain what is BIF and all. Okay, let's come back to my whiteboard again. So now coming to REF, guys, two different things. One is p value, which we have extensively discussed. Another one is called VIF, that is variance inflection factor. So what is that? Try to understand, guys. Okay, let me write down the formula. It will be easy for you. VIF formula is equal to 1 by 1 minus R square. Sir, what is R square? We don't know. You don't know. If you tell I don't know, then I'll tell, okay, don't attend my class. Have you remember in my previous past class, initial class itself, when I was talking about regression problem statement? To find out the important matrix in case of a regression problem statement, I told you there is something called RSS, residual sum of error. There is something called TSS, total sum of error. There is something called R square. And we have figured it as R square. So to find out VIF value, you should have to know R square. Then how to know R square? So I have told you R square is nothing but 1 by RSS divided by TSS. That means now you find out R square. Again, R square depends upon RSS and TSS. So how to find RSS? RSS is nothing but I told you it's nothing but error term, right? E square, right? So something like that. So what is that? Can I write? It is nothing but Y actual minus Y predicted square. So what is TSS? TSS is nothing but total sum of square, means E1 square plus E2 square plus En square, En square. Okay. So that is nothing but, so sorry, this is R square. Sorry. TSS is nothing but Y actual, that will be correct, minus Y mean square. Have you remember? I have shown you one data set with my Excel sheet. I have shown all the formula I have drawn. So you have to find out TSS by taking this value. You have to find out RSS by taking this value. Put these two value and find the R square value, and put R square value in this formula and find the VIF. It has again the threshold value and all. If my VIF value, threshold value, I'm talking about the threshold value. If my VIF value is greater than, let me see the threshold value. Yeah, VIF is less than or equal to 0.05, then you have to consider that column. If it is greater than 0.05, then you have to reject or drop that column. Clear, guys? Any doubts so far? Any doubts so far? Clear?